Hello dear friends, welcome to the lecture of ordinary differential equations. In this lecture we shall study order, degree, types of solutions of differential equation and also how to form differential equation. Differential equations are mainly of two types, ordinary differential equation and another partial differential equations, and these are very important in mathematics because almost every phenomena can be written, whether it may be physical, chemical, biological, etc., can be written in terms of differential equation, or a mathematical model can be formed containing differential equation of these phenomena, and therefore differential equations are important. Here I have written few definitions which are simple to understand. We shall see the meaning of these. A differential equation is an equation that involves differentials or differential coefficients. An equation involving differential, that is dx, dy, dz, etc., or differential coefficients, means it may be of the form dy by dx or higher order d square y by dx square, d cube y, etc. So equation involving differentials or differential coefficients is known as differential equation. And next, ordinary differential equations are those which contain differential coefficients of a single independent variable. So ordinary differential equation contains total derivatives. So that means if we consider y as dependent variable and independent variable as x, means y is a function of x, only of single variable, then the equation the derivative will be total derivative, and such total derivatives will be there in ordinary differential equation. Partial differential equation, there we have to consider a function of multivariable functions, means function of more than one variable, two variable, three variable, etc. And in that case we have to take the partial derivatives, and therefore that type of equations, differential equations, will be known as partial differential equations. But here we are studying only ordinary differential equations. Now next is the two terms associated with differential equation. The first is order. What is the order of a differential equation? That is the order of the highest derivative appearing in it. So we will see the examples, then it will be clear. So highest derivative we have to take from the differential equation, and the order of that highest derivative is the order of the equation, differential equation. And next is the degree. Degree of a differential equation is the degree of again the highest derivative. So order and degree decided by the same highest derivative term. So that is here it is order and here it is degree. Degree of the highest derivative, when condition is when the differential coefficients are free from radicals, means fractional power and fractions. So that should not be at the denominator. So that is the meaning of degree, and this will be clear by considering examples. Now we consider examples. First we will have like this, say dy is equal to sin x dx. I shall write the equations first, few equations, then we shall see what is the order and degree. So these are the examples of ordinary differential equation. Second example I shall write as d2y by dx square plus 2dy by dx. Any example we may consider 3y is equal to x square. Third I shall write 1 plus and next I shall write as so these are differential equations, because differential equation is an equation involves differentials or differential coefficients. Now here this first equation involves differentials. Dy is a differential of y, dx is differential of x. So dy is equal to sin x into dx, that is a differential equation. And what will be the order of this differential equation? Or actually this equation can be written as, or this implies, now see this dx can be transferred on this side, or that will be dy by dx is equal to sin x. It is equivalent. And now we shall decide the order. Now order is the order of the highest derivative involved in it. So our order of the differential here. Now this differential of first order, this is the differential of first order, and that is the highest order differential involved in the equation, and therefore the order of this differential equation is 1. So that means, or here you can see the order of this derivative is first order, and therefore this is the first order differential equation. Equation 1, or the equations, the above equations, one is, for these the above equations have one. For the above equations, we may say, for the above equations, one is of first order, yes. And what about the degree? So order is the highest order derivative, and the highest order derivative is only dy by dx. And what is the degree? Degree is the degree of the highest order derivative. Again the highest order derivative is 1, and degree means the power of this, and we see the power of this derivative is 1. Power, not the derivative, so it is 1. So therefore the first equation is of first order and first degree. Next, see second equation. Second, here you see, first we shall decide the order, and here what is the highest order derivative term involved in the equation? See, this is first order, this is the second order, and therefore the highest order derivative term is this one, and the order is second. So second is of order, is of is of second order. Order is 2. And what about the degree? Now degree is decided by the same term, the degree of this term. Now this is order, but degree means power of this. So this term is repeated only one times, and that means this power is, index of this term is 1, and therefore is first degree. And 3 is of third equation. Now for the third equation, see what is the order of this equation that we shall decide. Now we should, and we have to decide the degree also, and but you see, to decide the degree of the equation, so the equation, this equation can be written as, you can transfer this term on this side, so it may be written as 1 plus dy by dx, the numerator is 1 plus numerator, and this term, if we transfer that term on the right side, then that will be x times d cube y by dx cube. So therefore we may write that term as see, I shall write it here, 1 plus dy by dx square to the power 3 by 2 is equal to x into d cube y by dx cube. Now in this equation we see what is the highest order derivative involved in this. So actually the order of this derivative is first order. Order and the power should be separated, you see. And the order of this right side derivative term or differential term is 3, and therefore third order is the highest order. Third order is the highest. Or further, to decide degree, the equation must be free from radicals. Radicals means fractional power. So we don't want this fractional power, and for that purpose we have to square on both sides. So squaring we get, see, what we shall get is 1 plus dy by dx whole square, and after squaring, raising the power to 2, this 3 by 2 becomes 3 after squaring, is equal to, and right side is x square and square of this d cube y by dx cube square. Now observe this equation. So first, it is better to write the equation free from radical and fractional. This is all fractions means at the denominator, terms at denominator we should write at the numerator on simplification. And now we can now decide the order and degree of this equation. Now what is the highest derivative term involved in this? It remains the same. Here also it is the same, d cube y by dx cube. So therefore that is the order. So this is third is the order of the differential equation. So third equation is of third order. And what is the degree? Degree is whether this will be 3 or 2. So degree is again decided by the derivative of highest order, power of or index of that derivative, and it is 2. So this is order, this is degree, and third degree. Now what about the last one, fourth equation? Fourth equation should be, again, to decide the degree, it should be free from fraction, and for that purpose we multiply both sides by dy by dx. So this is a third example we have simplified. Now fourth can be written as we multiply by dy by dx, so it is y into dy by dx, and minus x is equal to dy by dx into dy by dx, that is dy by dx whole square, multiplying throughout by dy by dx. And now decide its order and degree. Now what is the order of this differential equation? Highest order derivative involved in the equation. Now it is free from fractions. Here it is fraction. So x divided by dy by dx is a fraction. And so we have made free from the fraction. To make it free from fraction, we have to multiply by dy by dx. Now highest derivative involved in it is what? Which one? Whether first or second. See, dy by dx, it is dy by dx square, but the order of the derivative is only first. This is first order derivative, it is a square of first order derivative, and therefore first order is the highest order. And the fourth equation is of first order. And what about the degree? Degree of this, so first order, so this is first order term, this is the first order term, but what is the degree of that term? Means maximum power of that term, and that is second. So therefore this is second order, second degree, not order, second degree. So this is the meaning of order and degree of an ordinary differential equation. Now we shall see types of solutions of differential equation. First we shall see the meaning of solution. So which is called, or which relation is called solution of a differential equation. That is written here. A solution, it is same as an algebraic equation. So if we have the equation of this form, simple equation I shall consider, x plus 3 is equal to 0. So what is the solution of this equation? We say that value of x which satisfies the equation, and clearly it is x is equal to minus 3. So if you put x is minus 3, then this equation is satisfied. The same meaning is there for solution of differential equation. A solution, or which is also known as integral, of a differential equation is a relation between the variables in terms of dependent and independent variables, which together with its derivatives satisfies the differential equation. So that relation and its derivatives must satisfy the given differential equation. Then it is called a solution or integral. So why it is called integral? Because so we obtain the solution by integration of a differential equation. And now there are here we should consider the types of solutions. First is the general solution, the solution which contains a number of arbitrary constants equal to the order of the differential equation is called general solution, or which is also called complete integral. So the solution containing the number of arbitrary constants, there will be arbitrary constants in the solution. We shall consider the example, then this will be more clear. Arbitrary constants, and that number of arbitrary constants, suppose it is 1 and the order of the differential equation is also 1. So that means the number of arbitrary constants is equal to the order of the differential equation. These must be the same. Then that solution is known as general solution or complete integral. And what about the next solution? Solution obtained from the general solution by giving the particular values to arbitrary constants are called particular solutions. So here the arbitrary constants are there in the general solution. If we assign particular value to these arbitrary constants, or by imposing given condition, under the given condition we can obtain the arbitrary constants value, and if you put the values of the constants, the equation becomes particular equation or particular solution. The solution becomes general solution becomes particular solution. That means particular solution is obtained from the general solution. So we consider example. Consider the differential equation. And that I shall consider d square y by dx square plus y is equal to 0. So this is a differential equation that we shall consider. Now how to obtain the solution of this differential equation, that we shall see. If I consider y is equal to sine x, then that is a solution of this differential equation. So it is very easy to verify. What is the y? This must satisfy the equation. Y together with, we have written the solution is a relation. So this is the relation, is the relation between the variables y and x, which together with its derivative, this and its derivative. But see, the equation is having second derivative. So therefore we should have to obtain the second derivative. So what is the first derivative of this? It is cos x. Derivative of sine is cos. And what is the second derivative? Derivative of cos x is minus sine x. And now you see, if you put d square y by dx square as minus sine x, this is minus sine x, y is sine x. So minus sine x plus sine x, put these two values in this one. So that becomes 0. So therefore this is a solution. And now if we consider y as sine x is a solution, then y is equal to a into sine x is also a solution, where a is a constant, arbitrary constants, or any constant that we shall see. So what is the difference between arbitrary constant and constant? Arbitrary constant can take any real number value. We can assign any value. A may be 1, 2, 3, etc. That is known as arbitrary constant. But if I consider a as 5 sine x, then 5 is a fixed constant. 5 is a fixed constant and a is arbitrary constant. A can be assigned any value. Infinitely many values can be given for a. So that is the difference in arbitrary constant and a constant. So this is also a solution. You can verify, because what is the dy by dx? It is a cos x. So a, because a is constant, a remains the same. And what is second order derivative? Minus a sine x, and y is plus a sine x. So that is equal to 0. So therefore this is also a solution. Y is equal to a sine x. Similarly, we can see that if I consider y is equal to cos x, and then that is also a solution, because what is the dy by dx is see, dy by dx is minus sine x, and d square y by dx square is minus cos x. Minus cos x plus cos x is 0. So this is also a solution. and again we can see y is equal to b cos x is also a solution of this differential equation. So this is very easy to verify. You can verify like this, and thus this is also a solution. So that means there are number of solutions. Sin x, a sin x is also a solution, cos x, b cos x is solution. That means, and if you consider a any value, 2 sin x is also a solution, 3 sin x is also a solution, or minus half cos x is also solution, etc. So number of solutions are there. But if you consider y is equal to, say, then y is equal to, I shall consider the combination of these two, and that is a sin x plus b cos x, then this is also a solution. So you can verify what is the first derivative will be a cos x minus b sin x, and the next derivative will be minus a sin x and again minus b cos x, and therefore that the sum of these two, second derivative of this and itself, is 0. So therefore this is a solution. So any combination of these two solution is a solution. And now you see here how many arbitrary constants are there? A and b. A and b are arbitrary constants. So that means there are two arbitrary constants. And what is the order of the differential equation? Order we have seen the meaning, it is second order. So the order of the differential equation, number of arbitrary constant is equal to the order of the differential equation, and therefore this is a general solution of 1, is a general solution where a and b are arbitrary constants. Is, we suppose this is second, is the general solution of 1. And now we can see what is the particular solution. So what we have written about particular solution, solutions are obtained from the general solution, from this, by assigning particular values to the constants. So here a and b are constant, we can assign any value. So if you take that constants can be decided by imposing some condition, that is y 0 when y dash when x is 0, y is 0, etc., or when y dash is 1 when x is 0, like this. That conditions will be there, and that determines the value of the constants a and b. So given conditions, using the given conditions we can get the values of a and b. And if you take the value of a, so if you take a is equal to, by given conditions, a is equal to, suppose a is 2 and b is 3, then the general solution 2 becomes y is equal to, see, a is 2 sin x plus 3 cos x. Now this is known as particular solution. So this is particular solution. Third is particular solution. This is a particular solution of 1 of first for this differential equation. So that is the meaning of general solution and particular solution. General solution contains the number of arbitrary constants equal to the order of the differential equation, and if we assign or give particular values to the constants, then we get a particular solution. There is also a third solution which is known as singular solution, but we shall not study the singular solution now. We shall study singular solutions afterwards. So this is about the general solution and particular solution of an ordinary differential equation. The formation of differential equation we shall consider in the next lecture. The problems on formation of differential equation we will continue in our next lecture. Thank you.